Hello everyone, myself Diyashash. Currently I am pursuing my BTech third year in Electronics and Communication Engineering from RCC Institute of Information Technology. I have a good idea about the HTML, CSS, JavaScript, Java, C, Python, DBMS, SQL and also in data structures and algorithms. So this is a brief introduction about myself. Now let's discuss about my this project. This is basically a group project named as Algorithm Visualizer. Here we used mainly sorting and searching algorithm logics to implement this algorithm visualizer. Basically, we had to face a lot of problems to understand all of these algorithms clearly when we read it actually. So we think to make this one because because when we learn anything theoretically along with a visualization, then it's easy to understand for us. Besides that, we can memorize this for a long term too. So this is the main motto, or this is the main reason for which we decide to make this one. Now let's come to the demonstration of this project. So this is the home page of our project. They are the team members. This is the title of our project, Algorithm Visualizer. And here you can see that icon is here, a moon icon is here. This is basically a mode change icon. This is basically an icon for changing the modes. It is by default lighting mode. If we click in this button, then it's changed into the dark mode. Then it's shift into the dark mode, and there is a hamburger menu from which you can see the different fields or different pages of our project. It's basically along with home, sorting visualizer, searching visualizer and about us. So if we click in this home button, then it's direct to the home page. Then it's direct to the home page. And if we click this sorting visualizer button, then it direct to the sorting visualizer page. If we click this searching visualizer button, then it will direct us to the searching visualizer page. And this is the about us page. So now if we click to the sorting visualizer button, then let's see. If we click it, then we can see that this is our sorting visualizer project. So first of all, if we hover this one, then we can see that the sorting visualizer, if we click this, then it will refresh this page. And this is a generate new array button. If we click this one, then random arrays are generated here. And this is a slider to adjust the number of arrays here or sizes of arrays here. If we decrease this, then the number of arrays are decreases. If we increase this, then the number of arrays are increases. So we can see that the maximum size is 100 and the minimum size is 4. We can easily adjust by just adjusting this slider. And this is the speed slider. We can also adjust the speed slider when a sorting is taken place, then we can easily move this one and easily we can adjust the speed of the sorting. And whenever we click any of this sorting button, then the sorting process is started, and as well as the sorting, how we can do the sorting, like the codes are also showing in the below. And besides that, the time complexity and space complexities are also shown here. So let's check one by one. First, we have to click in this generate new array button. Then you can adjust the array size from here, and then you can click this bubble shot button if you want to show the bubble shot. Whenever you click this bubble shot button, as we know that what is bubble shot, like we know that in bubble shot it take the highest element from the array elements and put it at the end of the array, and then after that the second highest element at the second last position is taken, and like that the sorting is processed. So here also this logic is implemented and you can see it visually along with the sound, and when the whole sorting process is done, you can hear it by a sound and you can actually understand how the sorting process is going on. So let's see the bubble shot. So as you can see that it first take the highest element from the array and put it to the last, and like that the process is going on. Now if you want to see the code for the bubble shot, you can easily scroll this and you can easily copy this code from this. It is a bubble shot code. It's a logic of bubble shot in Java language. This is the time complexity and this is the space complexity written here. So this is all about the bubble shot. Now if you want to see the selection shot, then you again have to click this generate new array button, and then you have to go for the selection shot. And in selection shot, as we know that selection sort is basically take the smallest element from the array and put it at the first, and then after that the whole process is going on, then it put the second short element and put at the second place of the array, and like that the sorting process is going on. So let's see the selection shot visually. So as you can see that, as I tell before, you can see it visually. Now go for the code section. So this is the code for the selection shot. It's all written in Java. You can copy from here, and this is the time complexity and this is the space complexity of selection shot. Now let's move to the next sorting process. And for insertion sort, as we know, it first divides the array into two parts. One part is sorted and another part is unsorted. It first take the elements from the unsorted part and sort them and put it into the sorted part. Like that the sorted elements are increasing and the unsorted elements are going to decrease. So like that all the elements of the array are sorted like this process. So let's see it visually. Insertion sort button. If you decrease the speed, you can see that what will happen. Let's see the code for the insertion shot. So this is the code for the insertion shot. As you can see that this is the code. You can copy the code from there, and this is the time complexity and space complexity of the insertion shot. Let's move to the next sorting process, which is merge sort. In merge sort, as we know, this merge sort is using recursion process, and in this sort we have to apply the divide and conquer rule. That means first we can divide the arrays into some parts and then conquer them. First we have to divide into smaller elements, then we sort them, and then we can add them. This is the whole process of the merge sort. Let's see it visually. For this, again we have to click this generate new array button. We can increase the speed and we can easily visualize this merge sort. Let's see it. So this is the visualization of the merge sort. Let's see this merge sort for a big array. So then again we have to click this generate new array button, then we can increase the array size, and let's see the merge sort again. It will too much interesting. So as you can see that this is all about the merge sort, and again you can get the code of the merge sort from there. This is the code for the merge sort, and this is the time complexity and space complexity for the merge sort. Now let's move to the next sort, which is quick sort. So we all know that quick sort is the best sorting algorithm to sort the array elements. So as we all know that the quick sort is the best sorting algorithm to sort the elements of any array. So the two main terms which are related to this quick sorts are pivot and partition. So this pivot can be taken as random, as median, or first element or last element of the array of the elements. But here we take the last element of the array as pivot, and then taking the last element of the array as pivot element, we can easily do this quick sort process. So let's see this quick sort process visually. So for this we have to again click this generate new array button, and then we have to click this quick sort button, and let's see visually what will happen. So you can see that how the quick sort process is going on and how it's completed. So let's see this quick sort again for a smaller array too. So for this we have to click this generate new array button, and then let's decrease the size, and let's again see this quick sort. Here you can see that whenever a sorting process is going on, then all the other buttons are disabled. All the other buttons are disabled except this speed slider. All other buttons are disabled then. This array size button is also disabled then. Whenever one sorting process is completed, only then other buttons are enabled. So let's see the code for the quick sort. This is the code for the quick sort process. This is the time complexity and space complexity for the quick sort. So this is all about this sorting visualizer page. Here you can see bubble sort, selection sort, insertion sort, merge sort, and quick sort visually. So now move to the searching visualizer page. For this you have to click this home icon, then it's direct to the home page. So now you can, clicking this button, you can go to the searching visualizer page. So this is the searching visualizer page. If we click this searching visualizer, then it refresh the page, and if we hover this, you can see this effect. And here are also same buttons like generate new array, size slider, speed slider, and the array bars. And here whenever a searching process is done, if the elements are found, then it will show the elements index, and if it's not found, then it's showing that it's not found. And here we can easily see the linear search and binary search visually. So let's move to see this. As we know that first we have to click this generate new array button, that's generate the random array bars. So let's click this generate new array button. Its all functionalities are like sorting pages. If we click this generate new array button, then random arrays are generated. Then if we click linear search or binary search button, it will show the respective sorting process visually. And then it's also showing the codes, time complexities, and space complexities for the respective searches. So let's move first to the linear search. For this you have to click first this generate new array button, which produce a random array bars. Then you have to click this linear search button. But before clicking this linear search button, you have to put first a value which you want to find from this array bars. So this number must be in between 20 to 350. So let's put a number between 20 to 350, suppose 50. Then you have to click this linear search button. As we know that there must be a key value. that which value I want to find from the array of elements. We have to first take this value. Like here I given a key as 50. Then we have to compare this key value like 50 with all of the array elements present in the this random generated array bars. Whenever this key value is matched any of the array elements, then the key value is fine from the array elements, and then it's showing here. Let's see if it is present here or not. So let's see this visually. So as we can see that 50 is not present in the array, and if we put some value like it's present in the array, then what will it's showing? Let's see this. First click in this generate new array button. Let's search for 156. Let's put here 156 value. Now the key value is 156. Now this 156 key value is compared with all of the array values, like all of the array bars present here, and whenever it will match, then it shows this bar only. Okay, so let's see this linear search visually. So as you can see that 156 is present at index number 33 and the step count is 34. Okay, so this is all about the linear search. Let's see here the code of the linear search. This is the code of the linear search. This is the time complexity and space complexity of the linear search. Now let's move to the next searching process, which is binary search. So for this, first we have to click this generate new array button. Then we have to put a value again which I want to find from this array of bars, and then we have to click this binary search button. Before going to this visualization process, what we know about this binary search? Like in binary search, we need a sorted array first. It is the must needed for binary search. Like for binary search, first we have needed a sorted array. For linear search, we didn't want any sorted array. We didn't require any sorted array. But for binary search, first we need a sorted array, and then from this sorted array we have to find the mid element from this sorted array, and then after that we have to compare this key value, like what value we have provided in this box. Then we have to compare this value with the mid value. If the key value is greater than the mid value, then we have to start our searching process from mid plus 1 up to the end element of the array. But if the key value is smaller than the mid value, then we have to start our searching process from the starting element up to the mid minus 1 element. So this is the whole process, how the binary search is going on. Let's see this process visually. So let's put a number which is present here, suppose 291, and let's see the binary search process visually. You can see that first it finds the mid element here from here, and then it only searching all of the elements before the mid plus 1, because this is the mid element which is 157 and 291 which is the key value. First it will compare with this, and if we can see that the 291 value is greater than this mid value, so it started find its searching process from the mid plus 1 up to the end element of the array, and by this process it can easily find the 291 array element from this array bars, from this random generated array bars. And you can see that 291 is present at index 53 and the step count is 5. And you can easily see the code for the binary search. This is the code for the binary search, and this is the time complexity and space complexity for the binary search. And now if you go to the home page, then click this home icon. and it's direct you to the home page again. And let's see the last page of our project, which is the About Us page. Let's click on this About Us page. Then you can see that they are our team members. This is me and these are my team members. So click this home icon. If you want to again go to the home page, then you can click this button and it will direct you to the home page. So this is all about our project. Lastly, I want to say thank you to my team members who helped me a lot to do this project properly. Hope this project and this video session will help you to understand about the algorithm visualizer properly.